Okay, now members, in this lesson we are going to see the cosine rule, or what some people call it the cosine formula. Let us, there are two here, there are three, there are more than one, that's why here I'm using the cosine formula. Now here, we are going to see that if sine rule fails, we can now use the cosine rule. We have seen that sine rule works under three conditions. Now, if those conditions are failing, then you can bring in the mighty cosine rule. Let us divide it. Consider the triangle ABC below. So this is my A, B, C. We said if this is B, this one becomes small b. This is A, the opposite side becomes small a. This is capital C, the angle. Then the opposite side becomes, from here up here, becomes small c. Now, if I do a line from here up here perpendicular to this, then instead I'll be creating a right angle triangle here and right angle triangle there. So using triangle APC, see if I use PC, now we don't have this side. So by that I can use now the Pythagoras Theorem. Then this side squared plus this squared will be equal to the longest side squared. That's what I'm doing. So the whole from here up here is CP plus x squared will be equal to b squared. If I make CP squared the subject, because I don't know CP, the subject. Then using triangle BPC, triangle BPC is that also now this side is squared plus this side is squared, which is C minus A, then this square. Now, if from here up to here is X, it means, but from here up to here is C, it means that the balance here is going to be C minus this, we shall be getting the balance there. So that's what they are doing here. So CP squared plus this squared, which is C minus C squared, will be equal to the longest side, which is A squared. And then here expanding, when I expand this, then after I take it to the other side, because this one you don't know it, that's why I'm making it the subject. Then when I expand this, we have this squared, then this and this by 2, then plus this squared. That's what we have. Then when we open brackets, this minus, then this minus and this minus gives us a positive, then the minus and the positive, we have a negative. So this is equation 2, this is 1. So that this is CP squared and this is CP squared. You note that CP squared is equal to this, so this equation is equal to this. So 2 is equal to 1. So now I go to this, now this, because all of them are CP squared. Then I have this, so that this squared is going to cancel, this x squared is cancelling. Then when I make a squared or something, when I take this side, it becomes a positive. When I take now this the other side, it becomes a negative, and that becomes equation 3. Now, I don't want xy because x is not known. Because the triangle I used, I add angles ABC and sides ABC. So I want to remove now this. Which triangle can I use? Now you see, from here, if I want to remove this x, I can't use side y, because side, we don't know this side. And we don't know, this one is x, I want to remove x. I can't use side because side is opposite over the adjacent, over hypotenuse. But I don't know this side. That's why I'm going to use the cos. So cos A will be adjacent, which I want to remove. And then sine, B. That's why I use the cos. The triangle I'm talking about is this. So the adjacent x over hypotenuse B is equal to this. So if we cross multiply, so our x is going to be B cos A. That's equation 4. After doing that now, I have got my x, so I want to remove this x. That's why I'm saying put 4 in the 3, so that we can remove this x here. So to remove it now, so that I'll be having now, when I put it here, I'll be having B, C, cos A. Then I rearrange it in that order. And this is what we have as our cosine rule. Now, similarly, if you use this same idea, just changing the angles and the sides, you'll be having b squared equal to 2. Now note, if you have a squared, the angle here is A. Then the two other remaining sides, you add their squares and multiply them. So if you have b squared here, you will have b here as the angle. Then the remaining side is the square of those sides plus the product of those two sides. If you have c, then this is c. Then the remaining sides, a squared plus b squared, then their product minus 2 of their product because of the angle there. Now, when do you know that we use sine rule? We use sine rule if we are given two sides and an angle between them. Another way, all the three sides and no angle given. Now here, for example, this is given two sides and the angle between them. You see that they are giving us these two sides and the angle between them. Now here you can't use sine rule. Why? Because sine rules needs a complete pair, the angle and the sine. But you see here, we don't have any complete pair. So there you can't use sine rule. So it has failed to bring in the cosine rule. Now for cosine rule, it's that we need, remember, if this is A, this one is going to be small a, this is B, this one is going to be small b, and this one is going to be small c. Remember that our c is the same as the AB, and they want us to get the length, find the length AB. Now, it means that now I'm going to use cosine rule. Why? I have these two sides. So I have these two sides, and the angle between them, which is the angle C. So the only angle we have is C. Now, I'm just going to substitute into the formula. So my C squared will be my A, the opposite angle to angle A is 12 squared plus B, my B is 15 squared, then minus the product of 12 and then 15, then cos of C, the angle now C, which is 30 degrees. And from there, all you are left with is to get C squared. Instead when I multiply this, I'll be having, this will be 144, okay, 144 plus 225, then minus, when you multiply these two, you get 360 cos 30 degrees. Now from here, you get a square root of the whole of this. So that our C is going to be the square root of, when you add this and that. So that will be 369 minus 360, then cos 30 degrees. And from here, just press your calculator. Then minus so the answer I'm getting is 7.5651 centimeters. 2, I'm giving it for the small braces and then underline. So that's how we use the sine rule. Okay, so by this you can, if you be okay with placing them at once, you can from this step you can come directly to this step and then you get a square root. What you shouldn't forget is after doing this, I get a square root of the whole of that. And that will be the answer. Now, from here now, they want to solve this triangle. Solve the triangle, saying you get all the sides and all the angles. But we have all the sides, meaning we want the angles. So here you can't use also sine rule. You can't use because you don't have any angle. You can't use the sine rule. So you bring in the cosine rule. Now from here, instead now we have PQR, meaning that our functions, our formulas are going to change now from ABC to PQR. These are dynamic variables, they can change always. You can be having X, Y, Z, and so on. So meaning now, if I set the first, P squared will be Q squared, R squared minus 2QR, then cos of the sine there. As simple as that. Now that we are interested in the angle, what we do, we make cos P the subject. How am I making the subject? You see, I bring this side and I take this side. So I'll be having 2QR when I bring this side. Cos P equaling to Q squared plus R squared, then minus when I take this side, P squared. I want, because I want this side I want angles, that's why I want to make this the subject. So that from there, my cos P will be Q squared plus R squared minus P squared, the whole over 2QR. So if you know how to do that, the rest are very, very easy. Allow me now to try it here. Now, this one meaning is going to be our P, this is going to be our Q, and this is going to be our R. So just substitute and then we get cos of P. So it's that my cos of P is going to be, now my Q is here, 7, then squared, then plus my R is 3. squared, then minus p squared. My p is 5 squared. The whole over 2 times q, which is 7, times r, which is 3. And from here, your cos p, you first give this one to 4 decimal places. So, this is 49 plus that, plus 9, that's 58, minus 25, divided by, instead this one is going to be 21 times 2, that will be 42. This is 21 times 2. So here I'm getting 0.787. Okay, let me clean it so that it's this enough. 5, 7. Then you get your p as cos inverse of 0.7857. And so our p becomes I'm getting 38 point. We give angles to 2 decimal places. 2 decimal places. Similarly, now I want to get cos. Now I have got b. Now let me get cos q. I mean the angle q. There, if we get the angle q, it means that now its side is the one that is starting inside. So now q squared will be equal to 2. Now the two sides is squared plus r squared, remaining 2. Then 2pr, then cos of the angle next to that. To make this the subject is that now our cos q will be, we take this side, so p squared plus r squared minus now q squared, the whole over these coefficients 2pr. Because we are taking this side, it will be positive, then that's why this one goes that side to become negative. So now our cos q is going to be, we substitute our p squared. Our p squared is 5 squared plus r, which is 3 squared, minus q. Our q is 7 squared, the whole over 2 times 5 times r, which is 3. And from there, you can easily get straight away your angle there. So I'm getting a negative, then you press shift cos of the answer. I'm getting 120 degrees. Then if you have that, you know now you have all the angles. You have the 2, then you can get the third. So that r p plus q plus r will be 180 degrees. From there, you have your p already there. So that our p is 98.21 plus our q is 120 plus r equal to 180 degrees. And from here, that our r is going to be 120 plus 38.21. So mine is 21.79. So from there, it's that. Okay, if not this enough, let me write it properly here. Now from there, my r is 21.79 degrees. So we have solved the whole of that triangle. We have all the angles, then we have all the sides. So here, this was giving you negative 0.5. So then you say cos inverse of negative 0.5. That's how you get that. So that's it, members. I wish you well.